we can start to wait a few minutes for someone else to arrive.
Hello.
Okay, we can start with this session. The topic is concrete, is inside the Technical Committee 09, which I chair. The title is Innovative Material Strategies for Structural Integrity. Chaired myself and L.Restuccia, who is not here, unfortunately. The first presentation is presented by Dr. Falliano, and the title is Innovative Crystallizing Materials for Waterproofing Concrete. Please.
Good morning, everyone. I'm Falliano from Technical Theory. We changed a little the title in order to show something new compared to that we presented 2 years ago. So, today we will talk in this session on concrete innovation on a key aspect in concrete, which is the durability. And this is the definition given by our standard for durability. Maybe I can use it, yes. And design for durability is a very complex task but standard give us some advice on how to ensure durability in our structures, and here a valid list. And as you saw, the first point, the key point in that valid list was the choice of the material. And I had also the choice and the design of the material. Today we talk about the most used material in the construction sector, which is concrete. And you know that in the last few years, concrete technology made enormous effort, and just talk about dynamic casting system, for example, or about 3D concrete printing. Another in this field, another application is the 3D lightweight concrete printing. Here an example that we are developing in our department at the Polytechnic of Turin. We are able to make a synergy between digital fabrication and new cementitious lightweight material in order to realize components for building envelope characterized by lightness and by thermal properties much higher compared to all the material already present on the market. But today I will talk about another concrete engineered concrete, which is the engineered concrete to improve the durability. We can improve durability of concrete through the self-healing. What is self-healing? Self-healing is the phenomenon that leads to the growth of crystal on the opposite walls of cracks in order to partially or completely repair the crack. But we should emphasize that also traditional concrete is characterized by self-healing properties thanks to these two phenomena. At short curing times, the hydration of anhydrous cement particles, and at long curing times, the formation of calcium carbonate. But you can emphasize this property by means of a properly mixed design of the concrete in order to arrive to an engineered self-healing concrete. And this can lead to clear advantages. You can see the advantages here. The most important is this one. the extension of nominal service lipo structures. And in our research, this is an ongoing research. Today I show you the first step of this three-step research. And we are focusing on two different kind of structure. New structure, so design new types of concrete for self-healing, for durability. And we make this through an innovative liquid crystallizing admixture called admix plus. So with this solution, you can realize concrete structure characterized by self-healing property. But the other innovation is to improve self-healing in existing concrete structures. And we can do this by another innovative product called multi-seal. We can simply spray this product on the piers of a bridge, for example, on the reinforced concrete walls to make this concrete capable of self-healing. Just a few words about the methodology we are using. The first step, obviously, is the preparation of the samples, a lot of samples. Here you can see the mix design for the reference and the one realized with the additive, so the admix plus. The only difference is the presence of 1% with respect to the cement weight of admix plus. And regarding the other case, so the case of multi-seal, as I said, this is applied to an existing structure. So what we made is prepare a reference sample and then apply the multi-seal on this reference sample. You know that in an existing structure you could have two different possibilities. One, an undamaged structure, so a structure without presence of cracks. And the second possibility is to have cracks, so cracked concrete surface. So we test the two possibilities, applying multi-seal in undamaged sample and in damaged sample. But we wanted also to verify if the curing condition affected the self-healing ability. So we cured the specimen for 6 months in two different curing conditions, water and air, which is what you see when you go in a concrete site, in a construction site, so directly in air. And after this 6 months of curing, we made an ultrasonic pulse velocity test. So in undamaged condition, we, in this way, had a reference value. This is the crucial point of our research. So an assertedly homogeneous damaging of samples by means of a compression test. So in this way, we cracked our samples, damaged our samples. After this, just after the damaging, we measured another time the ultrasonic pulse velocity in order to define a leakage index. And after the damaging of the sample, we left samples for 3 months in another curing condition. We call it self-healing curing phase for 3 months. Also in this case, we wanted to analyze two different conditions that we can find on site. So in water, think to a foundation for example, or to a concrete, reinforced concrete tank, or in air but with spray water to simulate rain effect. For example, piers of a bridge. After these 3 months, we made another UPB test in order to evaluate the self-healing index and the recovery index, which are the indexes that make us the knowledge of the healing property of the concrete. Coming to the main results of this extensive experimental activity, the first comparative histograms are referred to new reinforced concrete structure. So this is the case in which we had the admix plus additive in the concrete mix design. And comparing the reference and the admix plus added concrete material, you can see that we have a lot of increase in self-healing index. This is referred to these pre-damage and post-damage curing conditions. But to highlight the influence of curing condition, here you can see, comparing in this case concrete additivated with our admix plus, you can see that if in pre-damage curing condition you put the specimen in air, then you will have a higher self-healing ability of concrete. Some picture of the closure of cracks in our concrete. While some comparative histogram refer to existing structure, so in this case we treated the concrete samples with multi-seal, and here I show you the influence of the curing condition in the pre-damage phase. Also in this case you can see that if the structure is a new structure realized with the admix plus, or is an existing structure treated with multi-seal, the conclusion is exactly the same. So the less samples have been watered before damage, the higher the self-healing ability of the conglomerate. And this is confirmed also in case multi-seal is applied in damaged condition. In fact, the previous graph refers to this one, refers to multi-seal applied in undamaged condition, so before the compression test I showed you before, while in this case the multi-seal is applied after the compression stress test, so in cracked concrete specimens. Finally, I show you the evidence of crack closure also for existing structure, and here you can see the conclusion. I said before that this is only the first step, because we are now evaluating the self-healing ability over time, so other 3 months of curing for this specimen, where when the self-healing ability ends, we will test the possibility to recover the mechanical properties of material with this product. And you know that these studies pave the way for new possibility to increase the durability not only of a new structure but also of existing one. Thank you.
Thank you, David. There are any questions? Please.
This material with what the cracks are filled, essentially.
This material?
The material that basically fill up the cracks. What is it?
The material is an industrial secret, but I can tell you that we have two different strategies to close the cracks. One is about the reaction of 2 components present in the additive. The second one is chemical additive present in the liquid that reacts with the CH present in the cementitious matrix, so the calcium hydroxide.
Okay.
So
it's
you have
something like concrete, similar to concrete.
No, it reacts with something present already in concrete, in cementitious material. Because the CH is produced by the hydration of CS3 and CF2, you have this material prompt to react in every age of the concrete. So it can react in every condition, you need only humidity.
Please.
Yes. Thank you for the kind talk. So my question is, if this technique increase the tensile strength compared to the initial tensile strength before cracking?
This is a very important question, because the answer is yes. If the concrete is not cracked and you apply this additive, you can have a slight increase of about 5% in compressive strength. But the important thing is that you can increase the durability, because you decrease a lot, about 75%, the water penetration depth in concrete.
Do the cracks only form on the outside, or because of environmental issues, or is there also cracks forming on the inside witnessed?
These cracks are from the outside and inside, because you use a compressive test after the peak force. We stop the test in the post-peak branch at 95% of the maximum force. So that samples are completely broken.
But
Outside and inside.
in real life?
Oh, in real life, no. The best thing we hope is to have only cracks in the concrete cover.
Yeah,
Not inside.
because the method probably doesn't work on the inside.
Yeah, but it can work also in the concrete cover.
Yeah.
Okay, thank you very much.
Thank you.
Pass to the second presentation.